When we put both inductors and capacitors in a series or parallel circuit, this is known as a tank circuit or a resonant circuit or a tuning circuit, and we get a special effect. Let's take the series one as an example. The inductor tries to let through low frequencies, but the capacitor tries to block them. Similarly, at high frequencies, the capacitor tries to let these through and the inductor blocks them. At some point, marked on the graph as F, the reactance of the capacitor and the inductor are equal to each other, and they cancel each other out. At this point, the only opposition left to the flow is the resistance in the wires, and this point is called the resonant frequency, and signals pass through easily. This frequency, the resonant frequency, can be easily worked out and is easily remembered from the rhythm of the formula. 1 over 2 pi root LC equals the resonant frequency. You might note, of course, from our previous discussions that this is a bandpass filter, and this, or the parallel version, which we'll come to in a second, is often used to select radio stations in cheap radio receivers. The parallel version is just the same, except that it's a notch filter. This time the resistance at the peak at the resonant frequency is called the dynamic resistance and is given by L divided by RC, where R is the resistance of the coil. This of course has a much higher value than the resistance in the series circuit.